Our dynamic universe. The key areas covered will be conservation of momentum in one dimension and in cases where the objects may move in opposite directions. What we will do today is state that momentum is the product of mass and velocity, and state the law of conservation of linear momentum. Momentum. Momentum is a vector quantity and is the product of mass and velocity. Momentum equals mass times velocity. Mass is measured in kilograms and velocity is measured in meters per second. The units of momentum are kilogram meters per second. Momentum is sometimes given the symbol p, which is why we can write it as p equals mv. The direction of the momentum is the same as the velocity. Momentum is always conserved in collisions. However, this will only be the case if the direction of momentum is also taken into account. The law of conservation of momentum. In any collision or explosion free of external forces, the total momentum remains the same. This can be applied to the interaction of two objects moving in one dimension in the absence of net external forces. For any collision, again with no external forces, the total momentum of all the objects before is equal to the total momentum of all the objects after. Here is an example for us to look at. Find the velocity of the trolleys when they stick together after colliding. Let's draw a diagram showing before and after the collision. So before the collision, we have the two individual trolleys, one of 3 kilograms travelling at 5 meters per second to the right, and one of 2 kilograms travelling at 5 meters per second to the left. After the trolleys stick together, so we've got a combined mass here, 3 plus 2 kilograms, travelling at an unknown velocity. So we can write out our equations for this. So our momentum 1 plus our momentum 2 is going to be equal to our third momentum. So replacing this with our equation, we've got m1 u1 plus m2 u2 is equal to, here we have our combined masses, m1 plus m2, multiplied by v. Let's fill in our numbers. We have 3 times 5 plus 2 times, here we have to put negative 5 because it's moving in the opposite direction. This is equal to 3 plus 2 multiplied by our v. So we've got 15 minus 10 there, so we've got 5 equals, and our 3 plus 2 is 5, v. So our v is 1 meter per second.